What I'm passing out now is forever more known as your tattoo. You're going to use this for the rest of the semester. If I know Kimber, she's going to laminate it. I would. Whoa, sorry, next door. As I knocked down the wall with my 2 hard the tattoo has everything you're going to use for the rest of the semester on it, nearly. It doesn't capture chapter 14, but it does everything else. So chapter 10, 11, 12, 13 is all on here. And guess what? Chapter 9 is too, except for limits. Okay? So let me show you what you've covered so far. I'll wait till you guys have got it. I'll hand it out and everyone has one in front of them. Okay. Jesus, this thing is gonna fall apart. Yummy. Nothing like a cold bottle of vodka. I wish. I wish. It's such pain right now. Give anything for a cold bottle of vodka.
Drink your troubles away.
Drink my troubles away.
Yeah.
I don't really drink, so I joke about it a lot, but I don't really drink.
We'll go with that.
Yeah. So they're coming towards you. Stand at the end like a happy puppy and get all my asses. Oh, dear God. Okay, this is your tattoo. What is a tattoo? I want you guys to check out. Sitting is good. Okay. I want you guys to look at the basics. This you already know. Plug an x into a function, get out a y. Y's can be positive, they can be 0, they can be negative. Plug an x into a derivative, get out a slope. Slopes can be positive, 0, or negative, right? A 0 slope indicates a maximum or a minimum or a horizontal point of inflection. Those are the ones that come down and pause for a second and drop again, or they come up and pause for a second and then climb again. That's an HPI, okay? They have 0 slope just at that spot. So far, so groovy. Plug an x into a second derivative, you get out a concavity. Concavity can be concave up, concave down, or 0. And a 0 is a point of inflection, right? A special, yeah, so wherever the first and second derivatives equal 0, those are critical points. That's where stuff is happening, right? And a special kind of spot where the second derivative equals 0 is the point of diminishing returns. You guys remember that? Okay. So that's that entire section. There's also something up here with little circles on them. Profit goes to marginal profit, cost goes to marginal cost, and revenue goes to marginal revenue. So that arrow from left to right indicates a derivative. So later in the semester, we're gonna go from marginal revenues to revenues, marginal cost to cost, and marginal profit to profit by integrating, okay? We'll get to that in a little bit, but for now, what else do we know? We know products and quotients, right? Over on the right-hand side, where we have a product, U times V, and a quotient, U divided by V. We also have the first 2 derivatives. We have the shortcut, x to the n, and we have d out dn, which is that u to the n. So you guys can make a note of that to the side. U to the n is d out dn, because what you're doing is nu to the n minus 1, that's d out, and then u prime is the derivative of the inside, or the derivative of the junk. So far, so good? And that's all we have.
Yay.
We've spent 7 weeks on just that tiny little bit. Today, you get this. All of the right-hand side except for the definite integral. Raise your hand if you've worked with logarithms and finite. Raise your hand if you worked with logarithms in college algebra. Okay, so you guys have all seen these before, except the derivative parts. And here's where we start. So I'm going to teach you guys that fourth derivative here. Under derivatives, I'm going to teach you the natural log of u. It really isn't that bad, guys.
Which one is it?
The natural log of u. It's the fourth derivative on the tattoo. You are going, and when I say tattoo, I mean you keep it with you. It should be with you every class. It should be with you on your exams, because guess what? You get this on your tests from here on out.
Oh, we get to like use it?
Yeah,
So we have 2 cheat sheets.
plus the cheat sheet. Yeah. Yeah.
Why don't you give this to us like the first test?
Because it wouldn't have done you shit for good, dude.
Have the products and quotients. And
Which you already had on your cheat sheet. Marco.
Should we be writing on this?
You can be. I will give you virgin ones for the final. I'll give you fresh, unadulterated tattoos for the final. But for now, you can scribble all over it. I don't care what you stick on it. Whatever helps you to remember the material. Okay? Logs are super sexy, fancy schmancy ways to solve for unknown exponents, guys. This is 11.1. Yeah. We've danced right through chapter 10. And we're on to 11.1, logarithms. Don't stress, guys. We're just getting it started today. We've got 20 minutes. We're going to finish it up on Wednesday. And do exponentials as well. They're fun. So let's look at the natural log of u. First of all, what is a log?
No idea.
Yeah, you do. Come on. What's 10 to the 0th power?
A log.
It's 1.
1. What's 10 to the 1st power? Yeah. Sorry, I got all excited. What's 10 squared? 100. What's 10 cubed? You guys starting to see a pattern here? Yeah. Yeah. So if I said 10 to what power equals 1,000, what would you say? You would say 3. Well, why? Because that's what it is. Grab your calculators. This answer is 3. So we're going to use the log button right now, not the natural log. We're going to work more with natural log, okay? I want you to write log of 1,000 into your calculator, because log of 1,000 is log base 10. Your log button in your calculator, LOG log, is already automatically base 10. It's saying 10 to what power equals 1,000. So we're solving for the power. So what is it? Yeah, it's 3. All logs do is they solve for unknown exponents. That's it. So we're saying 10 to this power equals that number. That's it. That's all they do. Sam? So what if I said 10 to what power equals 589? Well, where's 589? It's between what and what?
2 and 3.
Yeah, it's gonna be between 100 and 1,000, so your answer had better be between 2 and 3. So if you do log of 589, what's the answer?
2.77.
Oh. 2.77 exactly?
2.77011525.
So if you plugged that into your 10 to the power whatever, you would get out 589. You guys with me? That's all logs do. They're not special. They're not scary. It's all they do. Until we get to natural log. And they're not scary either. They're actually beautiful.
Oh, yeah.
Ah, let me show you why.
It can only be log base 10. Is that all we're gonna?
That's all log base 10. Now we're moving into log base
Okay.
E.
Okay.
Let me show you natural log of x. Because we work in slopes here. So natural log is ln. Okay, ln. So natural log of x, there's some neat things about this. First of all, there's a vertical asymptote here. It never clears x equals 0. If you try to plug natural log of 0 into your calculator, you're going to get an error out. Do it. Natural log is its own button, so ln of 0.
Is the natural log the same thing as just log?
No, it's base different. So log over there is base 10. This is log base e. And we'll talk about that in a bit.
But like to find like a, like,
If you want to change the base,
yeah.
like go to base 2, there's a formula for that. It's change of base on your tattoo towards the bottom on the log side.
Okay.
It's all there. Okay, so when you did natural log of 0, what'd you get? Error, right? Now try natural log of -4. And that will also give you an error because natural log doesn't exist to the left of 0.
Didn't give me there.
You didn't?
No.
Let me see. You should. I'm gonna do something to your calculator. Are you ready? Do you have anything programmed in there?
I do.
What?
Quadratic.
Mine gets an error.
Yeah, I have the quadratic program in there.
Making her mad.
I got it from that, so she doesn't put it in there.
Now try it.
Should I erase the program?
I hope I didn't. If I did, I'll reprogram it for you free of charge. Okay, there's another special, does it do it now?
Yeah.
Good. Now, there's another special thing. Natural log crosses at 1. So if you do natural log of 1, you should get 0. Natural log of 1 should give you 0. Okay? It crosses at x equals 1. You guys with me?
And this is gonna be true for all natural
This is
logs.
going to be true for all natural logs.
LN stands for natural log.
ln, yeah, log natural. I don't know why. It's backwards. It's backwards, but it is what it is. And here's the cool thing about natural log. The slope at 1 is 1. The slope at 2 is 1/2. The slope at 3, what do you guys think it is?
1/3.
Yeah, Psh, that's not so bad. The slope is 1/3 here. What's the slope at 10?
1/10.
Yeah, it's gonna be 1/10.
Wow.
1/10. So what's the slope at any x? Look at the pattern. It's gonna be 1/x. Not quite. It's gonna be the derivative of x over x. What's the derivative of x?
1.
So the pattern here is it doesn't matter what the subject of the natural log is. If you have y equals the natural log of some stuff, its derivative is the derivative of stuff over the stuff. Isn't that frickin' pretty? Isn't that pretty? It's actually really simple and really elegant. And derivatives of natural logs, not bad at all. Watch. What's the derivative of y equals the natural log of 6x cubed minus 10x squared? Y prime equals what, guys? Anybody want to take a stab? Look at the pattern. There's no natural log in the derivative. It's gone. Iman? 18? 18x squared minus 2 times 10 is good, divided by the junk. 6x cubed minus 10x squared, done. Very nice. Isn't that pretty? Isn't that nice? Do you like? I know I do. Let's do another, shall we?
And that's finding the derivative of a log.
Yeah. That's it. That's all we're doing. It's not bad, is it? Because that's what this is, x prime over x, right? So if we're saying natural log of x, if y equals the natural log of x, right, then y prime is going to be 1 over x, because the derivative of x is 1. So if x is 2, the slope is 1/2, and it just plugs right in there. Nice as pie. You guys with me? Change ten is happy. A little? Awesome. How about this one? Y equals the natural log of negative 8x to the 4th plus 5. What's the derivative, guys? Over? Damn, that's easy. There should be a button or something. Seriously.
There probably is, right?
What about this one? Y equals 6 natural log of x cubed plus 5x squared.
Uh-oh.
Do you just keep the 6?
Psh, constant coefficients go along for the ride, guys. They always have, they always will. 6 times, what's the derivative? Man, that wasn't so bad. Any questions so far? So up until this point, we took derivatives, we plugged in x's, and we got out slopes, right? Same. Take a derivative, plug in an x, get out a slope. That wasn't so bad. Yeah?
What if that was to the power? Would you multiply it
Yes, you would. That's such a great question. Y equals the natural log of x to the 4th plus, let's say 2x cubed, and this was to the 5th power.
It's the power rule, right?
It's a power rule, d out dn. What's the derivative of this, guys?
X, 4x.
How about 5 junk to the 4th times the derivative of the junk divided by the original function. How do you feel? There is
So-
nothing new here, guys. There's nothing new. So, Ryan, you said,
So this is just literally just a different form of everything that we've been doing. Cool.
yeah, that's it.
Are you gonna take it further to like quotient and product?
Yes, I am.
Like in that sense with like, would you?
I want to show you
multiply
guys.
things on the bottom?
I want to show, well, it gets easier than that. So can you guys imagine doing u prime v minus uv prime over v squared on this? And then over the original function? Look over on the right-hand side of your tattoo. There are shortcuts for you. Do you see the natural log of a quotient about 2/3 the way down, natural log of m over n? That's a quotient in there. How does that split up?
How come they don't use U and V?
Just because this is the way the textbook has it, so that if you go back to the text, you won't lose your shit, basically. You won't be like, why are they using M's and I'm using U's? This is not cool. So
It's basically the same thing though.
it's the same thing, yeah.
Natural
So if we have, so we just split them up, guys. So I want you to look at this one, and I want you to see something. This is the natural log of m to the pth power. It's the last one in that section. Natural log of m to a power. You guys with me? So what can I do with that power? I can drop it down in front. So let me do this one a slightly different way. What if I did 5 natural log of x to the 4th plus 2x cubed? Would I get the same answer if I took the derivative?
Yeah.
Yeah, I would, because watch. Y prime equals 5 goes along for the ride. Derivative would be 4x cubed plus 6x squared divided by x to the 4th plus 2x cubed, right? U prime over u, 5 goes along for the ride. This is the same as that. Here's 4 of them, here's 5 of them. So if I cancel out all of these, and I get rid of this guy, now I have x to the 4th plus 2x cubed on the denominator, and I'm left with 5 times this, 5 times this. Which one's easier?
The last one.
The last one. Using the shortcuts for natural logs are super useful. So very useful. So let's do one with a quotient just for giggles. So if you look at a natural log problem and it looks way too complicated to solve, go over to the right-hand side and look for a shortcut first. I just need you guys to remember those shortcuts are not derivatives unless they say specifically y prime. Okay? So these are not derivatives. Simplified, not derivative. Simplified, not derivative. Groovy? So how about this? Y equals natural log. Let's just make this a giant beast. Why not? 6x minus 10x cubed over x to the 5th plus 4 all to the 2nd power. Yeah, no one wants to do that, do they? Peel it. This is natural log of something to a power. What can I do with that power? Drag it down in front. No derivatives yet. 2 natural log of 6x minus 10x cubed over x to the 5th plus 4. Now split up my m over n. 2 natural log of 6x minus 10x cubed minus 2 natural log x to the 5th plus 4. So this involves a little more prep work before we go to the derivative, but it's worth it. Why did I put a 2 in front of both terms? Because it was tied to both terms in the original statement, wasn't it? This square applies to both of these. You guys see? So it's going to apply to both of them here. Now we're ready for the derivative. We have some simple natural log of u. Let's do it. Y prime equals what? 2 times 6 minus 30x squared over 6x minus 10x cubed, right? That's the first one. Minus 2 times 5x to the 4th divided by x to the 5th plus 4. I'm giving you guys tools to turn a god-awful derivative into something that's really manageable. We break it down into bite-sized pieces. And that's where we'll leave it today. But just for giggles, I'm going to give you guys the handout. Blink.
Just gonna say, is the 2 only part of the derivative? Or is it-
Only part of what?
Is the 2 on the outside on the y prime? Is
Yeah.
the 2 only